Hi everyone, today we're going to go over 3-4 system of equations and 3 variables. Last time we did systems of equations in 2 variables and 2-1 and 3-1. So we're jumping to 3-4. We're going to be using a lot of the same techniques as we did to solve 2 variables by hand. It's not really that big of a difference. This time we're usually adding a third variable, usually called z, but it could be another term depending on word problems and such. So one of the things we have is in our vocabulary now is an ordered triple, and this just means that our coordinate point is written in x, y, z in parentheses. So that it still determines a location. It's just now we're adding again a third variable. So we're going to head and take a look at systems with one solution, no solution, and many solutions. But we're going to start with the one solution. By using elimination, we're going to actually go ahead and get this down to a 2-variable system and then solve the 2-variable and then apply those terms into the third. So here we have, we're going to use elimination, and we have 5x plus 3y plus 2z equals 2, 2x plus y minus z equals 5, x plus 4y plus 2z equals 16. We're going to use elimination to get down to 2 variables. So the first one we're going to do is the first and second equations. We multiplied the second equation by 2 so that we can have opposite coefficients in our z term. So when we do that, we're going to end up with 9x plus 5y equals 12. So now we need to go ahead and use the third equation and any of the other two. In this case, we're going to use the first equation again and then the third equation. And we're just going to subtract it. So the biggest thing here is if you don't apply this negative by actually writing minus, 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 you need to remember that you're doing 5x minus x, 3y minus 4y, 2z minus 2z, 2 minus 16. And when we do that, we get 4x minus y equals negative 14. So since now we have eliminated z in both of them, we now have a 2-system, 2-variable system. So we have 4x minus y as well as the previous one. So we're going to solve the 2-variable system now. So we have our original system again, 9x plus 5y equals 12, 4x minus y equals negative 14. We're going to go ahead and multiply the second equation here by 5 so that we can have opposite coefficients for our y values. And so that when we add them, the 2 equations together, we are left with 29x equals negative 58. We can then solve for x and get negative 2 by dividing by 29 on both sides. Now that we know x, we can solve for y. So we're going to plug in negative 2 and simplify and find that y is 6. And so now that we know x and y, we can now solve for z. So we're going to plug x and y into one of the originals, and we get negative 4 plus 6 minus z equals 5. And when we simplify, we get negative 3. So our final answer again is written as a coordinate point. Negative 2, 6, negative 3 in parentheses is our solution. It is a coordinate point, so we do need to make sure we are including those parentheses as we write it. And as always, on all the you tries in the example for Check Your Progress, do go ahead, take a moment, pause the video, and try it to see where you stand. So here we have 2x plus 3y minus 3z equals 16. X plus y plus z equals negative 3, and x minus 2y minus z equals negative 1. All right, so what we're going to head is probably the easiest one to eliminate, actually, again, is going to be z. So we're going to add the first 2 equations. And when I add the second equation, I'm going to actually multiply everything by 3 to get 3x plus 3y plus 3z equals negative 9. And when we add them, we're going to get 5x plus 6y equals 7. And then I'm going to take the second equation, x plus y plus z equals -3. And I'm going to add it to the third equation, x minus 2y minus z equals -1. And when we do that, we're going to get 2x minus y equals -4. So we're going to go ahead and now we're going to eliminate another variable. So let's go ahead and do that in red. By looking at it, I have 5x, 2x, 6y, -y. It's going to be easier to eliminate y. So I'm going to multiply this equation all by 6 to get 12x minus 6y equals -24. So I'm going to cancel out my y's, and I'm left with 17x equals -17. And with that, I can solve for x and get -1. And now that I have my x value, I can solve for my y value. So I would probably go ahead and use 2x minus y equals -4. So I'm going to do 2 times -1 minus y equals -4. And we get -2 minus y equals -4. And by adding -2 and adding 2 to both sides, we get -y equals -2, which means y equals 2. So with that, we can now solve for z. I would use the second equation. So I'm going to use -1 plus 2 plus z equals -3. So we get 1 plus z equals -3. I subtract 1 from both sides to get z equals -4. So my answer as it ordered pair is going to be -1, comma 2, comma -4, all within parentheses, which is answer choice D. So that is good to know. One of the things I will make the suggestion is that when you're working these out, I know I've been doing it for a while. My Z's have a line through it. That way I know it's a Z and not a 2. It's very important to make sure that you don't confuse your variables with numbers. So if you have any variable that you're writing that looks like a number, make sure you can identify it as such. So that's why my Z has the line through it, so I don't confuse myself. All right, so now we have the system of equations that might have a no solution or an infinite solution. So they have a special look to them. So we're going to head and eliminate use y using the first and third equations. And when we do that, actually, we get 0 equals 0. Since this is a true statement, this actually means I have the possibility of having infinite solutions. But we need to make sure that the first and third planes actually intersect the second plane before we can say we have infinite solutions. And as long as I don't get a false statement, so like 0 equals 1 is a false statement, as long as I don't get something like that, then I'm good to go. So when they eliminated y using the third and second equation, we get 9y minus 15z equals 27. Since I get that, that means it does intersect at a line, so there is an infinite number of solutions. All right, so another way we can look at this is if we have no solutions. And so when we go ahead to eliminate x using the first two equations, we end up getting the same two equations almost, except they equal different numbers. and we get 0 equals -3. So this is what I meant by getting a false statement. So since this can never be true, this would be a no solution. It would be the same thing if that popped up. You had a 0 equals 0 and then a 0 equals 3 when you're checking your work for the infinite solutions. It'd become a no solution because as soon as you have that false statement, it's just not possible to happen. So what is the solution to the system of equations shown below? Go ahead and take a moment, pause the video, give it a try, and then unpause when you're ready to take a look at it. All right, so taking a look here, we have a couple options of what we'd like to eliminate. Looking at it, probably the easiest thing to eliminate looking wise is I probably would use the first equation, and I'm going to compare it to the second equation, the third equation here. Just seems like to be the best idea. So what I'm going to head and do, actually we're going to compare the first and second. So we're going to multiply the first equation by 3. That looks like to be the better way to go about it. And it takes a while for you to be able to look and say which ones would you be the best ones to compare. Because you will find the more you practice these, the easier you're like, oh, I have a feeling this is what it would be. And the more you practice it, the easier it is that you can actually recognize the best sets to go ahead and use, or what is the best variable to eliminate. It just takes practice and just seeing it enough to be like, that's the one. So using the first and second equation, I can see that everything's going to cancel out and I get a 0 equals 0. So I just need to make sure I don't get a false statement using 2x plus y minus z. So I'm going to head and use the first and actually I'm going to head and use the second and third. So we're going to use negative 3x minus 3y plus 6z equals negative 9. And I'm going to multiply the second one by 3. So we get 6x plus 3y minus 3z equals 18. The y's cancel out and I'm left with 3x plus 3z equals 9. So that works. I have a 0 equals 0 and I have an equation, so I can work with that. So that means I have an infinite number of solutions. All right, let's take a look at our next U-try. Again, pause as needed and unpause when you're ready to move on. All right, so here we're going to try and take a look. And so just like looking at, you're trying to see what would be the best one. I probably would go the first and second again. So we're going to head and multiply the first one by 5. So I get 15x plus 5y minus 5z equals 25. And we're going to add that to the second equation. Negative 15x minus 5y plus 5z equals 11. And we find everything cancels out over here and we get 0 equals 36, which is a false statement. So this is a no solution. All right, looking at our last example, we're going to take a look at a word problem. Usually when we're coming up with equations from word problems, the first two are going to be really simple because it's usually what are you selling, how much did you make, and then there's going to be something special about the third equation. So the first and second equations in word problems like these are fairly obvious. The third one is the one where you actually need to make sure you read correctly in what you saw. So here we have a stadium that has 49,000 seats. There's 3 sections. The top sells for 25, middle for 30, the bottom for 35. And the number of seats in the middle and bottom levels add up together to make the top level. and then all the seats sold for the event, we make $1,419,500. And the real question here is they want to know how many seats are there in each section. So I'm going to actually change the color of my pen. So again, 49,000 seats total. We have upper level sells for 25, middle for 30, bottom for 35. Middle and bottom level together equals the top level. And we know total revenue would be $1,419,500. So pretty much underlying, make sure you know what your key points are, and they just want to know how many seats. So the first thing you're going to do is actually identify your variables you want to use. You can use X, Y, Z is always a good default. In word problems, you might want to try and make sure you pick something that relates.
It is now the end of Sea Lunch.
To the problem. So in this case, we're going to use U for upper, M for middle, and B for bottom. But when you find that you have a couple variables or terms that have very similar, X, Y, Z is always a good default. But always, if you're not going to use something that's fairly obvious, like U, M, and B in this case, you definitely need to label what each one is so that when you're working through it, you don't forget what is what. So we're going to come up with our three equations. So the first one's going to be the total number. So if I add them all up, I get 49,000, pretty straightforward. Next, I told you it's going to usually be a cost, total, some money to some other thing that we have here. So we know the total revenue. So we know 25U plus 30M plus 35B equals our lovely 1,419,500. And the last part comes from reading that statement where it said the total number of seats in the middle and the bottom added together gets us our upper level. So that is why we have M plus B equals U. Notice it is slightly different compared to the other two. In this case, this works to our advantage. Sometimes, though, it's better to go ahead and change it so that it is in standard form. But it's kind of just a preference or depending on what you're going to do. So we're going to actually use substitution here. U equals M plus B, so we've already solved for U. I can actually plug that in. It works out fairly nicely. There's not really a lot of extra work with it, so it works out really great. This is probably one of the easier methods to use. So we're just going to replace every U with M plus B in the first equation and simplify. And the simplest form of this would be M plus B equals 24,500, which, that would have been helpful. Now we're going to do the second equation and replace U again with M plus B. And this will simplify to 55M plus 60B equals the total revenue. Now we're going to head and solve. So we're going to use elimination. We're going to multiply the first one by 55 and then subtract the equation to get negative 5B equals negative 72,000. So we're going to divide by negative 5 to get B is 14,400. Since I know B, I can solve for M. And we get M is 10,100. And since we know M and B, we can solve for U and get 24,500. I actually want to go back and look at a previous slide to where we probably could have figured that out earlier, that if we have known U, it makes things a little easier. If you go back to where we actually got right here when we had U equals M plus B, and we found that, well, when we simplify this, M plus B is 24,500. Here's another place you can be like, oh, that's the same thing as U. And that might have been helpful later on depending on how you wanted to work a couple things out. You still would have had to solve for MMB, but it's a nice thing that we can actually go back and check, like we did have U earlier. So taking a look at it, one of the reasons they did use substitution, it was actually the easiest way to solve this problem. We could have used elimination like we did earlier, but it just worked out easier. So you just check by substituting in the values and making sure you get 3 true statements. In this case, we do. So that is our solution. So go ahead and try solving the school store sells pens, pencils, and paper. The pens are $1.25 each, and the pencils are 50 cents each. The paper is $2 per pack. Yesterday sold 25 items and earned $32. The number of pens sold equaled the number of pencils sold plus the number of packs of paper minus 5. How many of each item did the store sell? So go ahead and try it out. There is a multiple choice portion of this, but kind of just because it's spacing wise, there's not an area to show your work. So I will show you the multiple choice after we work it out. So go ahead and pause, and then go ahead and unpause when you're ready to check your work. Let's take a look here. Again, one of the first.
It is now the beginning of D lunch.
All right, so one of the first things we're going to go ahead and do here is identify our variables. In this case, every word we're looking at starts with a P, so I'm not going to use the first letter of each one. Instead, I'm going to head and use X, Y, and Z. So I'm going to make pens are X, pencils, I'm going to actually write it here, is Y, and paper is Z. And that just makes it easier that I know what is what. So we're going to come up with my 3 equations, X plus Y plus Z equals 25. I also know they spent $32, so 1.25x plus 0.5z plus 2z, I'm sorry, that's supposed to be a y, 2z equals 32. And then my last one is going to be this sentence here. So it's saying pencils, so X equals the number, pens equals the number of pencils, so X equals Y, plus the number of paper packs minus 5. So I'm actually going to go ahead and rewrite this as X minus Y minus Z equals 5. So we're going to go ahead and do that. To me, I'm going to use elimination. That works easier. So what I'm going to head and do, I'm going to decide I'm going to eliminate Z. You just have to pick one and stick with it. So if I use that on the first and the last, because that's not going to, I don't have to change anything. We can do X plus Y plus Z equals 25. And we're going to go ahead and use X minus Y minus Z equals -5. And so I'm going to do, we're adding here. So we're going to get 2x. My y's cancel out. My z's cancel out. And we're left with 20. And we can actually go ahead and simplify this and get x equals 10. That's great and all, but we still need to actually get we need to get y. So I'm going to head and use the second and third equations. So we're going to have 1.25x plus 0.5y plus 2z equals 32. And I'm going to multiply the third equation here by 2. So that I can go ahead and add that and get, now we have 2x minus 2y minus 2z. And my mouse is starting to act up. And that equals negative 10. So we're going to add that up, and we're going to get 3.25 x minus 1.5 y equals 22. So now that we have our two equations, and the really nice thing here is we actually already know x, so I can go ahead and substitute that in. So I'm going to do 3.25 times 10 minus 1.5 y equals 22. And so we're going to get 32.5 minus 1.5 y equals 22. So subtracting 32.5 from both sides, we're going to get negative 1.5 y equals negative 10.5. And we find that when we divide by negative 1.5, we get y equals 7. And now since we know x and y, we can solve for z. So if I know x is 10 plus y is 7, I can solve for z. I'm going to use the first equation. And I'm going to get 17 plus z equals 25. And when we subtract 17 from both sides, we get z equals 18. I'm sorry, but my mouse is acting really funny right now. It's not wanting quite to do everything I want. I'm not sorry, not 18. I'm just 8. So z equals 8. So if I were to write this as an ordered pair, it would be 10, 7, 8. And looking at my answer choices, that would get me C, 10 pens, 7 pencils, and 8 paper packs. That is the end of our lesson. So that is variables and system of equations in 3 variables. And I will see you guys next time. Bye.